I think for the sake of time, we are going to start. So good morning, good afternoon, everyone, wherever you are streaming from. This is the East, Central, and South Africa Microsoft Excel Forum, brought to you by Crisp Excel Training and Consulting. These are our partners in Kenya and outside. Today, we are honored to have Owen Price. Owen Price is a Microsoft MVP. Areas of expertise is data strategy, data modeling, and Python programming. You can follow him on LinkedIn. He has extremely good content on LinkedIn. I'll share the link. His YouTube channel is a must subscribe for any person who is serious in learning about data management and data analytics. I'll also share his link. The topic for today is Python in Excel. So welcome, Owen, and you can start.
Great, thank you, and thanks for having me. It is I don't know what time it is there. 4 p.m. Oh,
yeah, 4 p.m.
4 p.m. there.
Yes.
It's 7 a.m. here. So it's a bit early, but I'm going to do my best for you. I put in the Q&A section. I hope you can click on the Q&A tab at the top of the Teams window. Put a question there to ask people if they have experience with Python. It'd be great to get some indication of the level of Python exposure that people have. So if you have experience, can you hit like that question if you can see it? If you don't have experience, let's say click sad face on that question. That's just an informal poll. Let me share my screen and then we'll get started. Okay, my screen is now shared and we are going to get started. So to begin with, I wanted to talk you through the availability of Python in Excel, how you can get hold of it right now. And yeah, that's what I want to talk about to begin with. So first of all, Python in Excel is on the Insiders beta channel. Insiders beta channel. So if you are not signed up for the Insiders beta channel, you will not be able to access it today. However, it is very easy to do that if you are willing to do that. You can literally just click this link or go to this URL and it will take you to this page. And then there are instructions on this page to join the Insiders channel. And once you've joined the Insiders channel, you will have to install an Insiders version of Excel or an update to Excel. You would go to the account section here and you'll see this button. This button is for Microsoft 365 Insiders. In there, you can select change channel and you will want to select the beta channel from this drop down. So if you want to use Python and Excel today or anytime soon, you need Insiders beta channel. That's the requirements for now. Let's move on. Okay, so I'm going to talk through the very basics of how to use Python in Excel, what it is, where it appears in Excel, just so that everybody's aware, regardless of your level of expertise. So when you have enabled the beta channel, you should then see this button group called Python Preview. These buttons, Insert Python, Initialization, Diagnostics, Reset, and Editor. We're going to talk through all of them now. So if we hit the Insert Python button, you will see a pane appear on the right-hand side of the window. And you can go through this tour and it will show you all of the basics of how to use Python in Excel. I'm not going to do that right now because actually I've never done it before and I don't know how long it would take. Then there are some examples here and you can press these buttons to insert a sample. I will select one of them in a moment to insert. Let's do this pair plot. So if I press this button, You can see that it's done a couple of things. It has loaded the famous iris dataset as a table. Then it has created a Python cell. This is actually a merged cell, which has an image, the output. And if I expand the formula bar, you can see a couple of things. First of all, a Python cell is indicated by this green line to the left of the formula bar with the letters PY. That tells you you're in a Python cell. And if you click in the formula bar, you'll see there is a little bit of highlighting, but not a great deal. And there's just some code here. I won't go through the details of what this code does, but you can see that it produces this chart based on this data set. A few other things to note are drop down to the left of the formula bar and select to output as an Excel value or as a Python object. Currently it's selected Excel value, which means it is taking what Python is bringing back to Excel and rendering it, drawing it on the grid. If I change it to Python object, it re-executes the code. You can see that now it's just the word image to describe what type of object it is. Then it's got this object placeholder, which has a show card pop-up, and I can click on the show card, and it gives me some details about what I've got. So I can add these, extract the size of the image to the grid, merge cell in the way. Okay, unmerge that and get rid of it. Let me unmerge this as well. Okay, so I'm going to click on this. I've got some actions, but if I click on the PY, I've got the card that shows me the image. I can press this button, put the image in the cell next to it. It's very small. I right click on there, picture in cell. I can press one of these three. Let's say create reference, and now I've got a reference to that cell. You can see it says H2 here. But the other options, if I click on the card again, is I can extract the image size. See that it's extracted the vertical and horizontal dimensions in pixels of the image, and it's a spilled array. Now, just a little thing I want to talk to you about. This card and what is displayed for this card is the standard output for an image. Python and Excel. So this is the card that you get when you create an image in a Python cell. If you create another data type, like a data frame or a list or a dictionary or any of the number of Python objects, this card will not have the same things on it. But further to that, if you create, and I only learned this last week, if you create a custom object which has properties that you have defined, there is a way that you can define exactly what this card shows in the code. I am not going to show you that today, but I will show you soon. The main reason I'm not going to show you is because I don't know how. So that's the object card. I've extracted two things. Well, when you have an image, a Python image in a cell, there are a few things that you can do. You can right click on it. You can choose place over cells. Has just created a big image, but now I don't have the code that it refers to. So that's not a recommended way of doing it. Second one is create a reference, which I did before. And then the third one is show preview. Show preview just shows me a preview of the image. However, I recommend that if you are creating an image, that you set this to Excel value so that the image is displayed cell like that. And when it's displayed like that, you will get this card button will create the reference quickly. Just do that. You can move this wherever you want, but your code is still in this cell. And when you select the image, you can see that it's pointing to the cell with the code in it. Okay. That's some of the basics of images. while we're here and we've got some code, I can show you a few other things. This initialization button to begin with. This code here is executed before you run any of your code. And the reason that they do that is to speed up how long it takes you to do what you need to do. So these are standard imports that people use for data analytics. NumPy is used for array and numerical processing, pandas for data processing. We've got stats model, Seaborn, Matplotlib, and so on. Right now, this is not editable. Future, this code will be editable, so you can put in your own definitions, your own imports, and your own maybe custom function definitions that you want executed right at the beginning of a Python session. And then that code will be executed when you load your Python workbook, and you will then not have to import NumPy as NP in any other cell in the workbook because it's already imported. If you're familiar with Jupyter notebooks, you can consider this as a imports and definitions cell at the top of your notebook, the very first cell that is run before anything else. But currently it's read-only. Later it will not be read-only. That's the initialization pane. The diagnostics pane is actually showing an error that I made earlier. But this is where if you use the print function in any of your code, it will output it to the diagnostics pane. If you have any errors in any of your code, it will come to the diagnostics pane. So you see that it also gives you, actually didn't know it did this, it gives you a link. You can click on the cell here and it will take you to the cell where that code is. I've since deleted that code, that's why there's nothing there. So this can quickly get filled if you have a lot of errors like I do. So you can hit this clear diagnostics button here to clear it when you're ready to start fresh. So that's diagnostics. The reset button is if you find that your Python cells are taking a long time, or there's just something has gone wrong, you don't understand what it is, you can hit reset to recalculate, or reset runtime to redo the initialization as well as recalculating. And most of the time that will fix any kind of connection errors that you might have. So if you suddenly had a disconnected network halfway through what you were doing, you can use reset runtime to start over. It doesn't clear any of your Python cells, so don't worry about that. It just reloads everything. So let's get to the interesting part, which is the editor. This is the editor. Glad it's back because this had disappeared from my copy of Excel the other day and I was worried. This is the Python editor. You can see you'll have a box for each Python cell. It will show you the Python cells on the sheet, current sheet by default. So if I go to this one, you can see some of the code that we're going to talk about later. But on the pair plot sample sheet, it just has one Python cell, so it has one box. In here, there are some things to note. First of all, this editor is the same editor that is used in the advanced formula environment. I mean, it uses the same component, which is the Monaco editor, as the advanced formula environment, which is the same editing component that VS Code uses. So most of the keyboard shortcuts that you can use in VS Code or in the advanced formula environment also work here. So I can share a cheat sheet that will give you some of those keyboard shortcuts later. There are some other options here. First of all, we can go to the cell, switch from Excel value to Python object here as well. If we need more space, we can expand the editor and it will fill, and then we can type away to our heart's content. And off at the bottom of each Python cell in the Python editor is an indication of what has been output. So the image has been output, and you can view it in the editor. And that is true also, even if you change this to Python object. I can press Control Enter to recalculate the cell. I can do that from the Python editor or from the formula bar or from the cell itself. And if I've changed it to Python object, you can see that it has more detail. It's PNG image file, but it still shows me the image without loading it to the spreadsheet. So you'll see later that sometimes this will say data frame, sometimes it will say spilled array, sometimes it will say list or value or any number of things. So the Python editor is definitely my favorite way to edit Python in Excel. It's probably the closest to what it's like working in a Jupyter notebook. So I generally try to avoid using the formula bar, and I use the Python editor instead because it's just nicer to look at. Okay, let's move on. I've now shown you all of these things. Let's pause for a second. Does anybody have any questions?
I can't see any. If you have a question, you can raise your hand and I will unmute you. There's none in the chat, so if any comes, I'll tell you.
And
let me. There's somebody who wants to ask a question. Senam, you can unmute yourself and ask a question. Sename.
Okay, hello.
Hi.
Yes.
Yeah, okay. A quick question. I don't have the editor button on my side in Python.
Okay, if you don't have the editor button, don't worry. I believe the editor is not present for everybody in the beta channel. It's only a percentage of the people in the beta channel, but I do know that it will become more available in the coming months. If you don't have it right now, please go and get the Excel Labs add-in from the add-in store, which is the add-ins button here. Get the
Yes,
Excel Labs
I have
add-in.
Excel Lab.
Okay, so go to the
Lab.
Excel Labs and go to the feature gallery, and you can select this version here, Python editor here. So the way they developed it is that they developed it in Excel Labs as an experiment to see what they could do. And once they became happy with it, they moved it into the beta channel. But it works almost the same way. You can see that it's got some differences. When I look at it in Excel Labs, it's showing me all of this fascinating stuff for the Python output, and the highlighting is slightly different. But it works in almost the same way. So it's a very good experience nonetheless.
Okay, thank you.
Anyone else with a question? I think we can continue, Owen, and then we'll
do questions at the
answer
end.
Question later on.
Yeah, sure thing. Yeah. Okay, so I have explored. This is, by the way, this is what the editor looks like when you don't have any Python cells. It's slightly different in text. Okay, so we've explored that. And next I want to go through some real life examples. This is actually an extension or a repeat of some of the content that I gave to a presentation last week, but I'm going to get into more detail because we have more time. So right now we are going to look at some survey data. Okay, if you've worked with survey data, maybe you know how difficult it can be to work with survey data. Typically you have one individual, one respondent for the survey on one row, and all of their questions, regardless of how complicated the questions are all across the row. So you can see question 7, all of these columns here just refer to question 7. Question 7 was just for each of the items you selected at question 6, please answer these 2 questions. In survey programming, that's called a loop, because you're supposed to loop through each of the previous selections and ask the same set of questions for each selection. So it can quickly turn into very many columns, which needs some restructuring in order to produce charts in something like Excel or Power BI or something like that, or really with anything. And it just so happens that Python is quite adept at dealing with this kind of data. So that's the example I'm going to walk through. Okay. Yeah. So first, the Python editor. Get the Python cells. Let's look at this one first. So the first thing I want to note is that when we are collecting data from the spreadsheet into Python, we use this Excel function. The Excel function either reads from a table or a range or a name or a Power Query. And if you have not loaded the Power Query to the spreadsheet, if it's a connection only Power Query, it will prefix it. Yes. So if you're not connecting to the table, but you are connecting to the query, see that it's prefixed with XLPQ. So in this case, I have a query called raw data. Use the Excel Python function, pull that raw data to a data frame called df. This Excel function, by default, it returns a data frame, a pandas data frame. A pandas data frame, if you've never used Python before, pandas data frame will be the most common thing that you will work with, probably. Excuse me. But let me just delete that, and I'll show you what it looks like when we actually do it. Literally just going to get the data and I'm going to do it in the cell. I'm going to get the data. So let me delete the Python cell. One thing I didn't mention earlier is that if you're just in the grid like this, just moving around with my keys, if I want to create a Python cell quickly, we'll just type equals py, then I will type tab. Pressing tab will create the Python cell. Okay, this is on Windows, by the way. I don't know what it is on Mac, but it doesn't matter because Python and Excel is not on Mac. So I want to create a data frame. I type df equals and then Excel. Then if I type the first open brackets, you can see it gives me the options of what are available. I am going to select this. Oops. Press tab, auto completes. Okay, and if I press Control Enter, see that it's both populated the data frame over here in the Python cell. And if I want to view the preview of the data frame or loading it to the spreadsheet, I can just do this. It shows me the first 5 rows, last 5 rows, and it has these this row of ellipses in the middle. That's just to give you an idea of the kind of data that you've got in your data frame. It tells you how many rows and columns there are. But this cell is here so that we can inspect the columns. So data frame, I can type columns, press Control Enter. It says index because the columns property of a data frame is the horizontal index across the top of the data frame. And if I expand this, you can see all the column headers here, but they're truncated. That's because this is set to Python object. I'm going to change it to Excel value, recalculate it, and then it will spill the data onto the spreadsheet. And you can see now that it says spilled values here. It shows me the first, I guess, 10 items. So the reason I've highlighted these lines here are to show you the relationship between the variables. So question 5 is, which of our attractions did you visit? And I think there were answers like restaurant, gift shop, museum, and so on. Question 6 is then asked for each response at question 5. And I forget exactly what 1, 2, 3, and 4 mean, but suffice to say that there are 4 answers at question 6 for 5_1, or 4 at question 6 for 5_2, 4 at question 6 for 5_3, and then question 7 continues that pattern. So for question 6_1, it then asks 2 questions. First of all, I think, let me see. What was your impression of this experience? And the second one is, would you recommend this experience? That is asked for each of the items within each of the 5 items. Question 6. So there are lots of loops, and this makes it great data to explore pandas data frames with. So I have pre-typed the code in this cell because it's somewhat complicated, but we can walk through it now. First of all, the goal here, the goal of what we're trying to do here is going to be to pivot, or I should say unpivot the data. So let me comment out some of this stuff so we can go through it one by one. By the way, in the Python editor, what I'm pressing to comment this is Control/. And that's the same keyboard shortcut you can use in the advanced formula environment and in VS Code. It toggles comments on and off. So we want to unpivot the data, but we want to keep these columns fixed. So on each row, we'll have the values from these columns, and everything else will be unpivoted. If you've used Power Query, you know that there is a unpivot other columns option, and that is exactly what we're doing here, but this is the way to do it in Python. So I have selected the first 6 elements from the columns index, which correspond to these items here. Then I've wrapped it in this list function. The reason being is that the next step requires this to be a list. You can't pass an index object into the next step. So that's the fixed columns. I've added some explanatory notes above the lines of code so you can read them, hopefully. I hope it's not too small. So this melt operation is a bit of a cryptic name, but it means unpivot. So what we're doing here is we're saying for the ID variables are going to be the fixed columns, which is these 6 columns here. And it will produce 2 other columns. 2 other columns will by default be, I think, attribute and value. Remember this from Power Query's unpivot. We can rename them, and we're going to have the variable name as question, value name as response. So let's see what happens when we melt. Control Enter. The melting operation is probably the most time consuming one to spill to the grid because it creates 20,000 rows, even though there are only, I think, 3,000 rows in the data set. So you can see that it has fixed the columns across every row, and then it has unpivoted questions 5 through 7 and the responses in here. I put this drop NA because in some rows, raw data, in some rows, there are blanks here. Yep. So when we unpivot, it doesn't automatically remove the blanks. It will unpivot them and they will remain in the data as NaN cells. And an NaN in Python means not a number, which is just basically saying it's empty. So if you ever see rows with NaN in them, or with the value error as it's shown on the screen, you can use drop NA, and that will drop a row if it has blank in any of the columns. There is a way to configure it to drop it if it has a blank in a specific column. So I suggest you read the documentation before using it. So for our purposes, actually, I don't need question 5 because the data that is embedded in question 5 is present in the variable name of question 6 and question 7. You can see after the first underscore, there's a 1 or a 2 or a 3, and those numbers there correspond to the values in these columns. So actually, we don't need these columns because we can extract the value for them from the variable name for the other questions. So the next step is I am going to perform a deletion, I guess. I'm going to exclude some rows. I've created this statement here is saying in the melted data frame in the question column, consider the values in the questions column as a string, and that gives you access to all of the string methods, the string functions. It says if the question column starts with Q5, this expression will return true. And if it doesn't start with Q5, it will return false. If we put a tilde before an expression that returns true and false, it will invert it. So it's the same as using the not function in Excel or using the double unary operation in Excel. So what this is then saying is just keep all of the rows that don't start with Q5 in the question column, because this loc is a locator. I'm telling it to locate all of the rows that do not start with question 5 and keep those and write them back to the melted data frame. So you'll see when I refresh this that these Q5 rows disappear. Okay, so the first one, there's no Q5 rows now, which is good. That's progress. So the next thing to do is we are going to assign, according to the pattern in this question column, according to those patterns, we are going to assign a new column based on some logic and based on our understanding of the data. So here, I'm creating a new column called variable, and variable is calculated by applying the assign variable function to the question column. What do I mean by applying? It means that the values from the question column will be passed one by one into this assign variable column. So to begin with, it will pass Q6 underscore 1 underscore 1. That will be the question passed into this function. It will say, okay, if question starts with Q6, and return experience. So the return value for this function will be experience for the first row, and for all of the Q6 rows, it will say experience in the variable column. For all of the Q7 rows, it will say impression if the sixth character, because they're 0 indexed, if it will say impression if the 6th character is equal to a 1. Otherwise, it will say recommend. And the reason I'm saying that is because you can see these 4 here have a 1 in the second numeric position here. These 4 have a 2 in the second numeric position. That's because these variables refer to the impression question, like what was your impression of this experience? And these variables refer to the recommendation expression. Would you recommend this experience? So that's what's happening here. Run that and see the new column, hopefully. Wrong. I've done something wrong. So a Python cell always outputs the very last statement. But because my last statement was an assigning of something to something else, there was nothing to output. So I've just typed melted df at the end there, and then it will output the data frame. Look at it. Time today. Okay, so this is the data frame, and you can see that the new variable column is here. And it says experience in these rows, and then impression, and then recommend, which is exactly what we need. So the next thing to do is to add some additional columns, and the columns are going to describe what the attraction was and what the experience of that attraction was. And it's saying, okay, what if the fourth character, we'll extract the fourth character from the question column. The fourth character is this 1 in the middle here, question 6. And for question 7, it's the first one here. That will be the value of the attraction variable. The experience variable is the last character in the question. So the last character for this one is experience 4. The last character, this one is experience 1, and so on and so forth. So this is just very quickly extracting bits of text from this question column. And it's really easy to do that in Python. You just give it the position, the zero-based position of the character that you want to extract. If you were to do this with an Excel formula, you would use the mid function. And I forget off the top of my head how to do it in Power Query, but it's very, very possible and very easy in Power Query. So let me comment that out. We'll apply these 2 steps, look at the new columns very quickly, and then just finish up on this part of the talk, and then I'll move on to the next part, which is arguably more interesting. Okay, got my new columns, attraction and experience, which are the extracted numbers from the question column. The next part is that now that I've extracted all that, this is not a good format for doing analysis. I actually want some columns. I want some columns. I want a column for experience, one for recommend, one for impression, and so on. So what I'm going to do is I am going to do a pivot operation. Probably familiar with this from other languages. Very common in Power Query to unpivot, do some transformations, and then pivot again. It's the same in Python. It's just slightly different syntax. So data frame in pandas has a pivot table method. The pivot table method creates a pivot table. So the first thing is we set the index. The index is essentially the row headers. So the things that will remain fixed on every row. What I'm doing here is I'm taking the list that we created earlier of those 6 variables, and I'm adding an item to the list. So when we use the plus operator with 2 lists, it will concatenate the lists. So now I have a list of the fixed columns and the attraction column. The variable column, which is this one, is going to be pivoted across the columns of the output. And the values for the pivot table will be taken from the response column, which is here. And the aggregate function, actually, we don't need an aggregate function because we are going to take every intersection of row and column. So I've just used first because it will achieve what we need. I'm going to run it without these 2 steps first, just so I can explain to you what they do. Okay, so we have pivoted the data. Now I have one row. Things have gone slightly wrong here. Impression, recommend. Right, so it's interesting. I think it's not rendered it properly. So to fix things like this, you can put reset index. And that will hopefully flatten the table properly. That's what resetting an index does. So now I have one row which represents the responses from questions 1 through 4 for each respondent, plus the attraction they went to, their experience at the attraction, their impression of that experience, and whether or not they would recommend that experience at that attraction. And then there are 1 row for each respondent for each attraction. So we have changed the granularity of the data. This last part here, rename axis, is because by default, each axis, you have an index axis, which is the row axis, and it typically contains integers that give you the position of each row, so 0, 1, 2, 3, and so on. And you have a columns axis. Each of those axes can be named. So in this output of this pivot table, the column axis is named variable, which is why we see the text variable here. To get rid of that, you can just rename the axis to an empty string. Rename the columns axis to an empty string. That's a quirk of data frames, which is probably a bit challenging to get used to. Okay, so this is the output. This is kind of in a good structure to do some pivot tables and charts, but we need some value. We need some descriptive text in these columns, and that's the next part. So, adding a new Python cell, and I'm going to grab the code that I've got in another window. Which is so what I want to do is replace all the numbers with text. There are many ways to do that in Python. The way I'm going to show you has several benefits and is a good way to do it. So let's just look at this to begin with. What I'm doing here is I am converting each of these columns to a category data type. What that means is that it retains the number in the column, but you can also add a label to that number, so a value and a label. The benefit of doing this instead of simply replacing the number with the text is that it will retain the order in which the numbers are ordered. So it will keep museum as number 1 in the order when you produce charts and so on, gift shop as number 2, and restaurant as number 3. So this code, this is a dictionary. A dictionary is made up of key value pairs. So 1 means museum, 2 means gift shop. This is a dictionary. You can tell it's a dictionary because it has these braces around it. This statement is saying replace the attraction column with the attraction column converted to the type category. Okay. And this line here is then renaming the categories using the attraction categories dictionary, which is this. So if I run just these, it will replace, you will see the descriptive text in this column instead. But all of this has been repeated for the experience categories, for the impression categories, and for the recommend categories. The recommend is much simpler. It's just got yes and no. So if I run that now, over here, we've got a new data frame. Preview if we want, but actually I'm going to change it to Excel value. Show it on the spreadsheet. Now I've got all my text. But this is actually not a great way of doing it. A couple of reasons. It's repetitive. So the code that we're doing here is the same code as this. It's just got different elements in the dictionary, and it's the same code as the 2 underneath as well. Further to that, we don't like to hard code data. This is data. We don't really want to hard code it in the code cell. It's better to manage data in a table or in a spreadsheet. So I'm going to show you another way to do this by having the data in this code frame sheet. Code frame, we've got rows here which represent the relationship between the code and the value for recommend, impression, experience, attraction, then some others which I didn't do. So let me expand that, and I will go over and grab the other version of this code. Place it. Okay, so instead of using hard-coded data this time, I am loading the code frame table into a new data frame called df value descriptions. And then for each of the columns that I want to categorize, I am applying the categorize function. And the categorize function, a function is indicated by def keyword, the name of the function, and then the parameters, and then the output. The types that you put here are optional. They're not enforced, but they're certainly very useful when someone else is reading your code. So my function accepts a series. When we say series in pandas, we're really talking about a column or a row. Most of the time, when you say series, you'll be talking about a column. It accepts a series, which is going to be one of the columns that I want to categorize. And it accepts the data frame that contains the relationships between the codes and the values. This is a comment describing what the function does. The first thing to do is to filter the data frame for the name of that series. So if I pass the recommend series, I want to just grab these two rows and use those to categorize the column. So that's what's happening. Excuse me. That's what's happening here. I'm filtering that in that value descriptions data frame. I am then zipping. If you've used Power Query, you're used to zipping. The zipping is basically taking two objects that are the same length. In this case, I'm taking two columns, the code column and the value column, taking two objects and combining them into a list of tuples. Tuple is an object with multiple elements. So in this case, the first tuple will be 1, yes. Second tuple will be 2, no. And then wrapping it in this dict function, excuse me, which converts the list of tuples into a dictionary. Finally, this PD categorical function lets us map the categories to the series and assign the category values as the new values for that series and set the order to true, which is to retain the original order. So this function is then applied to each of the columns that I want to categorize, and running this produces the same output. I'm very nearly done, don't panic. So it produces the same output, traction, experience, impression, and recommend, with all the categories done correctly. Now I'm going to slightly veer away from what I presented last week with an extra version, which I know you'll hopefully enjoy. One thing I noticed when I was writing this code is that each time I have to pass in this value descriptions table data frame into the function while this part changes. This never changes. I pass it in 4 times into that function. Now, I don't like repetitive code, so there is a way to do this where we don't pass it in 4 times. This is a very similar concept to something I'm quite a big fan of in Lambda functions, which is currying. Okay. Currying is when you take the arguments of a function. Let's say we've got a function of 2 parameters. Before we had a categorize function, which had series and data frame. We take one of those arguments and we extract it from that function and we put it in a function around that function. So in this case, I've created get categorizer using, which accepts one parameter, and that is the value descriptions data frame, the data in this table. And again, what it does is it returns this function, this get categorizer using. We pass the data frame and we get back from that function, a smaller function, which just has one parameter. That one parameter is the series. because it's already passed in the value descriptions data frame into the steps in that smaller. So the first thing, the way that this works is we collect the data from the spreadsheet. We get the data from the code frame spreadsheet. Then we create a categorizer function by using the get categorizer using function and passing into it the code frame. It returns this smaller function that is inside. So categorizer here, this variable, is now equal to this categorizer function configured with the data in our data frame. And now, instead of having 4 different lines of code for each of attraction, experience, impression, and recommend, we can just loop through the unique values in this feature column, get the unique values, and we'll apply the function once for each unique value. Excuse me. This is a list comprehension. So we're going to say columns to categorize. It's going to grab the column for each of the columns in unique values in that feature column, but only if that column exists in pivoted data frame columns index. So the benefit of doing this last if statement is that if we've got any code frames that don't exist in the pivoted data frame, they won't be. So this is now a list of columns. We can now apply the categorizer function to all of those columns at once and assign them back to themselves. Okay? So this is a much smarter way of doing it. It's an easier and more efficient way to do it. It doesn't hard code any column names. It just So that has done the same thing, but in addition, it has coded Q2 and Q4 because the code frame included code frames for it included codes for Q2 and Q4. So I could put as many descriptive relationships in this table as I want, and I wouldn't have to change the code to replace the numbers with the text, or to add the text to the numbers, I should say. There's just one more thing to show you, which is lost the code. Okay, we might need to skip the next step because I did have it in this other file, but now I don't have it. Let's skip the next step because I think we're out of time anyway. But the next step was to create a chart, and I don't have that code anymore, and I don't want to write it and make you wait. So, in summary, there are many things to learn here. The power of these Python libraries, I've barely scratched the surface. There is so much to learn. There is so many great things that you can do. I hope I've given you an idea of how you can get into Python and Excel, how you can get started, and some of the interesting things that you can do. There is a lot of overlap. You'll probably be thinking there's a lot of overlap with Power Query, but we know that Power Query can't create charts, and Power Query doesn't automatically retain the order of the text items according to their numeric equivalents. There are lots of other examples of what Power Query doesn't do that Python does do. As the very, very last step that I want to show you, if you get access to Python and Excel, I want you to go to more templates, and you can see I've got it here. But when you first open this, you won't see that. You type Python here, press search, and you'll see this Get Started with Python and Excel tutorial workbook, which is created by Microsoft, so you can trust it. And it's got some step-by-steps that tell you a lot of the things that I've just told you, but at your own pace, and it will give you some other examples that you can walk through yourself. So I really recommend walking through this workbook. with that, I've probably talked for way too long, but let me ask now, are there any questions?
That's too much to take in 1 hour. I have to say that myself. But I think I'll have to watch this webinar all over again. If there's anyone with a question, you can raise your hand. You can type it on the chats. I can unmute you. Before then, is there? I saw this. There was a tutorial being offered by Anaconda for beginners, Python in Excel. Is it a good place for people to start, or what would you recommend for any person who is interested to continue their learning from here?
Absolutely, yeah. Please go over to Anaconda, which is where I work. Get started with Python. There it is. Go to this Get Started with Python in Excel course on learning.anaconda.cloud. I'm not sharing anymore, and I'm because it's here. Go to this website. This is a free course. You can create an anaconda.cloud account and then access this course for free. And you can see it's got about an hour of content for you to learn, as well as a survey at the end. In addition, if you create an anaconda.cloud account, you will then be able to explore this add-in. This add-in is something that this is my job. I'm working with an engineering team to build this add-in. So it's in beta at the moment. We're still working on it, but it's improving every day. Let me just quickly show you that. It has the ability to save data to your cloud account, to save and retrieve code snippets, to create visualizations, and it also has this chat-based Anaconda AI assistant. The build visualization will give you a user interface for walking through some of the common properties of plots, and it will create the Python code for you. So we're building this visualization tool to allow you to get started more quickly and to select what you want to see in the chart. And then it will give you some code, which you can then just use as it is. You can study it, learn how to change it, and improve it. But that's the visualization tool. Then the code tool is too detailed for me to go into right now, but this is another way of writing Python in Excel, in Excel worksheets. But there will be more content surrounding what this is and how it works.
Okay, good to know. I don't see another question. Is there another question? I can see another question. Maybe the last question from me is, I always ask this to presenters. How has been your journey to where you are, and what can you recommend to somebody who up to you and they would like to be where you are?
Okay. So I started working with data probably in 1998. The very first data job I ever had was data entry. I went to an insurance company, and we literally had a stack of paper on a stand next to the computer. It was my job to type the data that was on those papers into an Excel spreadsheet. So I spent all day typing, and we had to check for errors and stuff like that. And then I moved on into a cash reconciliation team at that insurance company, where I learned how to use pivot tables and VLOOKUP and all of that stuff. And following that, I became I wanted to learn more. And this insurance company, they had a learning management system where I could learn about SQL Server. So I did that. I applied for a job in a different team as a business system analyst. I went over there and ended up writing SAS queries to query a mainframe and answer questions on a help desk. I was there for a few years, and then I moved to a company called Kinetic, where it was like a startup company. So I had a lot of freedom to learn and do whatever I wanted. And over the following 18 years at Kinetic, as the team grew bigger, I moved into leadership roles, and I went from individual contributor who writes access queries and builds access databases, went from that and builds VBA macros, moved from that through various different technologies, SQL Server, reporting services, integration services, writing some VB.NET, not much of that. But I was mainly going into leadership positions, so I was hiring people, and I eventually ended up as chief technology officer of that company. And that was in 2019. And then in 2022, I left that company. I needed a career break. And that's when I started posting on LinkedIn. And then I was doing some consulting work for maybe a year. And then I got this job at Anaconda. So if I were to recommend anything to anybody, it's to be curious and explore the things that interest you, because those are the things that you're going to want to spend time on.
True. Good advice. Good advice. Is there anyone else with a question? I don't see anyone else with a question. Owen, I think we can stop here. I'll share the recording, and Owen will also share the workbook that he has used for this presentation. There's a lot to learn from his code. I think when you get the workbook, you can go line by line, as Owen was doing, learning the different Python functions. Owen, thank you for accepting the invitation and for presenting. Is there anything else that you'd like to say before we end?
No, just thank you for having me.